Good morning students. Thank you very much students for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section I'm going to discuss about the origin of charge on colloidal solid particles. Okay, so that means the colloidal solid particles, how they will get the charge. So they carry charge students, how they are getting the charge. Colloidal solid particles, positive charge, negative charge, how they are getting the charge I'm going to discuss now. And I'm giving the best trick to understand the gold number students. On this gold number topic problems also I'm going to solving students. Okay number, now first of all, how the colloidal particles will get charge. See students, colloidal solid particles nana generally they carry charge students. Colloidal solid particles carry charge. So they are carrying charge students, they have charge. Okay, so colloidal solid particles absorb their colloidal solid particles absorb their absorb their own ions from the solution and become charged. From the solution becomes charged. Clear students? Colloidal solid particles absorb their own ions from the solution becomes charged students. So what is absorbing their own ions from the solution? Just one example, with one example I'm going to discuss students. See here, I'm taking here two test tubes students. I'm taking here two test tubes. Okay, two test tubes I'm taking students. Okay, so two test tubes. This is the test tube 1. This is test tube 2. Okay, now see students, in test tube 1 I'm taking the Ki solution. Okay, now Ki solution I'm taking students. This is test tube 1. Here Ki. This is which solution? Potassium iodide. In another test tube students, I'm taking here which solution? Silver nitrate solution I'm taking. Which solution? Silver nitrate. Are you clear? This is the silver nitrate, this is potassium iodide students. Okay, now this to this test tube, this Ki I am taking as excess students. I am taking this one as excess. This silver nitrate is excess students. Are you clear? This is excess. Understanding? We are taking excess. To the first test tube students, I am adding silver nitrate solution. So here silver nitrate solution we are going to add to this one. What we are adding? Silver nitrate AgNO3 solution we are adding. To the second test tube students, we are adding Ki solution. Which solution? Ki. Are you clear? So first here I am taking Ki, silver nitrate is added to the Ki. Here in the second test tube I am taking silver nitrate, Ki is we are adding. So that means here both the compounds are same only, silver nitrate Ki silver nitrate. But here in the first test tube Ki is excess. In the second test tube silver nitrate is excess when compared to Ki. Here Ki is excess when compared to silver nitrate. Are you clear students? So whenever silver nitrate is added to the potassium iodide, here, what compound, what is the colloid is formed? Silver iodide colloid is formed. Here also Ki, when it is added to the silver nitrate, here also silver iodide colloid is formed. Are you understanding students? Are you clear? In both the test tube students, silver iodide only formed. Okay, na? So now I'm going to take the equation students. Silver nitrate AgNO3 combined with Ki produces silver iodide colloid and potassium nitrate KNO3. Okay now, so silver iodide, it is the precipitate, students. It is insoluble precipitate. So this is the colloid. Are you clear? Now I have to find the colloid. Now in the first test tube, silver iodide. Here also which one is formed? Silver iodide is formed. Are you clear? Silver iodide is formed, students, in the first test tube. In the second test tube also, which one is formed? Silver iodide only formed. Are you clear? Silver iodide only formed, because both are same compounds. Now we'll get the same product, silver iodide colloid. Now in the first test tube, silver iodide is having which charge? In the second test tube, silver iodide colloid is having which charge? Okay now. So what I told you, students, colloidal salt particles absorb their own ions from the solution, becomes charged. What is the meaning of this one? See here, students. Here in the first test tube, silver iodide is formed. Kada? So silver iodide, this silver iodide absorbs the common ion from the excess solution. Okay, now in the excess solution in silver iodide, what is the common ion, students? Here and here, what is the common ion? Iodine, correct? Iodine is the common ion. Okay, now iodide, I minus ion is the common ion. And next here in the silver iodide, this silver iodide, it is a colloid. And here what is the excess solution? Silver nitrate. So this colloid, silver iodide colloid, it absorbs the common ion from the excess solution. It absorbs their own ions from the solution. Which solution? Excess solution. Here AgI, AgNO3, which is the common ion? Ag plus. This is the common ion. Are you clear, students? So Ag is common ion. Here Ag is common ion. Here which is common ion, students? AgI, potassium iodide. Which is common ion, students? Here AgI, potassium iodide. Iodine is the common ion. Here also iodine is the common ion. So this colloid absorbs the common ion iodide from the Ki solution. Okay now. And here iodide which charge, students? Actually Ki dissociates into, here which in this first test tube, students, in first test tube Ki dissociates into K plus and I minus. In the second test tube, in second test tube also, students, this is silver nitrate. It is dissociates into silver nitrate. Silver nitrate dissociates into Ag plus NO3 minus. Are you clear? Ag plus NO3 minus. So here which ion is common ion in the first test tube? Iodine. Are you clear? This is the colloid, silver iodide colloid. Are you clear? Silver iodide colloid is formed. Are you understanding? Here also silver iodide colloid is formed in the second test tube. In this colloid, this is excess. It is a common ion is iodide. So that's why when Ki, now see, students, when silver nitrate is added to the potassium iodide solution, silver iodide is precipitated, okay, which absorbs the iodide ion from the solution. Are you clear? Here what I am saying, students, silver iodide. So when silver nitrate is added to the Ki, when silver nitrate is added to the Ki, what is happened? Okay, silver iodide is formed. Okay, now the silver iodide absorbs, what absorbing? Absorbs the common ion. Which is the common ion in the first test tube? Absorbs the common ion iodide, I minus, okay, from the solution. Clear, students? Ion from the solution, students. I minus ion from the solution. Are you understanding? When AgNO3 is added to the Ki, produces silver iodide. It absorbs the common ion I minus from the solution. So that's why here Agi I am taking. This is the first test tube, students. This is the first test tube. Okay, first test tube. So here AgI, it is absorbing the common ion I minus, this AgI. Okay, common ion is I minus. So that's why here I minus ions are I minus ions. It is absorbing I minus, I minus, I minus. That's why AgI colloid, because of this I minus ion, silver iodide will get the negatively charged colloid, because here negative charged ions are occupied. So that's why silver iodide, because of this I minus ion, silver iodide will get the charge negative. Are you clear, students? So that's why here in the test tube A, silver iodide charge is What is the charge, students? Minus negative charge, correct? So that's why we can represent it as AgI. AgI, this is AgI collide, students. This which charge? I minus. Are you clear? So what is the charge of AgI? Minus, negatively charged collide is formed. Now I'm going to discuss the second test tube. Now see, students, in the second test tube what happened? In second test tube, okay, in second test tube, silver iodide is formed. Here potassium, when potassium iodide is added to the silver nitrate solution, silver iodide is formed, correct? When Ki is added to the which one, student? Silver nitrate produces which one? Silver iodide collide. This silver iodide collide absorbs the which ion, students? Common ion. Absorbs the common ion from the excess solution. What is the excess solution here? Silver nitrate. What is the common ion? Ag plus, correct? Ag plus ion. So that's why common ion Ag plus from the solution, from the excess solution, clear? From the excess solution, students, excess solution will get which charge? Positive charge. Okay, this one from the solution will get which charge, students? Will get negative charge. Okay, this is negatively charged collide kada. So this is a negatively charged collide, and here this is a positively charged collide. So silver ion, silver iodide. So here I am taking the silver iodide collide. Around this, which ions are occupying? Ag plus ions are occupying. Ag plus ion. So that's why here Ag plus, Ag plus, Ag plus. Because of this Ag plus ions, the silver iodide will get which charge, students? Will get positive charge. This is nothing but origin of, okay, origin of charge on colloidal Sol particles. Clear, students? So like this, the colloidal particles will get the charge. Understanding, students? So main thing is the colloidal Sol particles absorb their own ions from the solution, becomes charged, students. Are you clear? This is nothing but colloidal Sol particles charging. Okay, Nama. Next one, best trick. I'm going to discuss the best trick to understand the gold number. Okay, Nama. Gold number. See, students, now I'm going to discuss about the gold number, Nana. So first of all, I'm not giving the definition. I will discuss with first of all example, students. Now that time you can understand. After that I will give the definition, Nana. See here, gold number. So first of all, solutions are classified into three types. Correct or not? What are the types, students? Solutions, true solutions, colloidal solutions, suspensions. Correct. So solutions are classified into three types. Classified into three types, students. First one is true solutions. True solutions. Okay. Next, second one is colloidal solutions. Colloidal solutions. And third one is suspensions. Okay. Three types are there. So true solutions, what is the particle size, students? Particle size is less than 1 nanometer. This particle size is 1 nanometer to 1000 nanometers, and this particle size is greater than 1000 nanometers. Are you clear? This is the particle size. And again, these colloidal solutions are classified into two types: lyophilic colloidal solutions, lyophobic colloidal solutions. Two types are there, students. So there are how many types, Nana? Again, colloidal solution is classified into two types. What are the two types? Lyophobic colloids, lyophobic colloids. Are you clear, students? Lyophobic colloids. Here in this, lyo means what, students? Lyo means solvent. Philic means what, students? Loving character. Okay, and here lyo means solvent, and phobic means, what is phobic, students? Phobic is nothing but hating character. Are you clear? This is hating character, phobic. This is a philic loving character. Are you clear, students? Lyo means solvent, philic means loving. Lyo means solvent, phobic means hating character. Okay, now I'm going to discuss lyophilic and lyophobic colloid, students. I'm not discussing more, just some points I will discuss, students. Lyophilic and lyophobic. See, students, lyophilic colloids, lyophobic colloids, correct? So here I'm taking Nana lyophilic colloids. Examples what, students? Lyophilic colloids. What are the examples we can take? Lyophilic colloids. Examples, Nana, gum water. Okay, na, we can take gum water. Next, starch water. We can take examples. Okay, lyophobic colloids. Lyophobic colloids. Example, students, gold. Gold sol we can take example. Okay, gold sol. This is the example, students. Now see, we know that lyophilic colloids are more stable, lyophobic colloids are unstable, students. If I take gum water, for example, I am taking here one beaker. This is the gum water, students. This is the which water? Gum water. Okay, gum water, students. This is a gum water. Now, on standing for a long time also, the solution is stable. So that means here we won't get any precipitate, students. It is stable solution. Are you clear? Gum water, it is stable, Lana. On standing for a long time also, on standing for a long time also, the solution is stable. Are you clear? The solution is stable. Here we won't get any precipitate, students. After some days, if you observe also, the same solution will get back. So that is calling as stable solution. But if I take lyophobic colloid solution, it is unstable, students. See here, I am taking here one beaker. This is the gold black. This is the water I am taking. Here one gold block I am taking. See, students, this is the gold block. This is which one? Gold block. Okay, this is the gold sol. Gold sol. It is unstable solution, students. It is unstable. On standing for a long time, students, this on standing for a long time. Okay, on standing for a long time, the solution, the solution is unstable. Are you clear? The solution is unstable, students, because it is not stable. Here, what are the gold particles are there? That gold particles are come closer to each other. Understanding? Come closer to each other and forms the lumps, students. Here, what it is forming? Lumps are formed like this. Okay, so lumps are formed. This is nothing but precipitate. Are you clear, students? So this is calling as precipitate is forming. Are you clear? That means it is unstable solution. On standing for a long time, it is unstable. So that means here we'll get the precipitate, students. Gold particles are come closer to each other and forms the lumps. Are you clear? That is calling as precipitate. Precipitate is formed. Now we want to make the lyophobic solution should be stable, students. How to make it? Now see, students, how to make it. I am taking the lyophobic colloidal sol. Lyophobic colloidal sol. Now this is the gold sol solution. This is the gold sol unstable solution. Okay, now it is a gold sol. To this gold sol, I am taking this gold sol 10 ml solution. I am taking how much? I am taking 10 ml gold sol. You are taking, students, 10 ml. Okay, now so 10 ml gold sol when we are taking here, to this gold sol we are adding 1 ml of NaCl. We are adding 1 ml of NaCl solution. Okay, now it is 10% NaCl solution. solution, students. 1 ml, just 1 ml you are adding 10% NaCl solution. 10% is nothing but what, students? 10% means what? 10 grams of NaCl is present in 100 ml of water. Are you clear? 100 ml of water, students. So, and whenever 1 ml of NaCl electrolyte is added to the gold salt, what will happen? It undergoes coagulation. Are you following? Coagulation, and here lumps are formed. Are you clear? Here lumps are formed. Okay. So, whenever we know that whenever to the colloid and electrolyte is added, coagulation taking place. Are you clear, students? So, that means here unstable. Here coagulation taking place. Here coagulation is easy. Are you clear? Here coagulation easy. Here coagulation takes place? No, coagulation does not take place. Are you following? Here coagulation does not takes place. Are you clear, students? That means precipitate is not forming. Here coagulation takes place. Whenever electrolyte is added to the colloids, that only coagulation, correct or not? What is the coagulation? Precipitation of the colloidal particles. That means the colloid is converted into the precipitate. So here we will get the precipitate lumps are formed. This is nothing but PPT, students. What is this? PPT will get. So that's why to stop this PPT, that means we want to make the it is a unstable solution. We want to make this lyophobic solution stable, students. Okay, it should be stable. So that's why what I am doing now here to prevent the precipitate, students, here I am going to add lyophobic colloidal salt. Okay, now so here from this side I am adding lyophobic colloidal salt we are adding to this solution. How much we are adding? Just milligrams, students. Just milligrams when we are adding. Okay, now when we are adding in milligrams, just small amount when we are adding to the solution, automatically that means the precipitate is disappears, students. Are you clear? So whenever adding 1 ml of NaCl, the precipitate is formed. That means the gold salt undergoes coagulation. Okay, now and after that when we are adding lyophobic colloidal salt, because lyophobic it is stable solution, when we are adding lyophobic salt to the lyophilic solution gold salt, what will happen, students? Okay, now what will happen, Nana? It prevents the precipitate, students. Are you clear? So that means to protect the coagulation we have to add lyophobic colloidal salt. When we are adding lyophobic colloidal salt, students, to the gold solution, lyophilic colloidal salt protects the gold particles, students. Are you clear this one? It protects the gold particles. Lyophobic colloidal salt particles protect the gold particles, students. Are you clear? Hence gold particles will not come closer to each other because they are going to come closer to each other. So that's why they are forming the precipitate. Whenever lyophobic colloidal salt is added, what will happen, students? Lyophobic colloidal salt is added. This is the gold particle. Suppose I am taking the gold here Au particles. I am taking just Au means gold particles. Around these gold particles, what is lyophobic? Sorry, what we added? This is lyophobic nama. So here we are adding lyophilic. Sorry, students. Sorry. Lyophilic colloidal salt we have to add. This is lyophilic. This is lyophobic. Nana, lyophobic. So we want to make the lyophobic solution. This is lyophobic solution gold salt. We want to make the lyophobic solution should be stable. So that's why we are adding lyophilic colloidal salt. We are adding what we are adding? Lyophilic colloidal salt in milligrams we are adding. So whenever lyophilic colloidal salt is added, what will happen, students? Around the gold particles, one protective layer is formed, students. So that means around gold particles here protective layer is formed like this. Are you understanding? So this protective layer, which one, students? This is the lyophilic salt. Okay, Nama, lyophilic salt. So that means because of this protective layer, students, these gold particles cannot come closer to each other and they cannot form the precipitate. Before they are come closer to each other and forms the precipitate, whenever lyophilic colloidal salt is added, it is forming the protective layer. Are you clear? This is what, students? Protective layer. protective layer. Understanding students, layer around the gold particle. So this protective layer prevents the coagulation, students. That means here the gold particles are not come closer to each other, and that means coagulation does not takes place. Are you clear? So here coagulation does not takes place. Coagulation does not takes place. Are you understanding, students? That means the protective layer, it protects the coagulation. Okay, Rama. So this is the gold number, students. Now I'm going to discuss the gold number definition, students. Now see, Nana, what is the gold number definition? Gold number. What is the gold number? It was proposed by gold number. Now, who proposed this one, students? Zygmundi. Okay, proposed by Zygmundi. Okay, Nama. So, what is the definition, students? The amount of lyophilic sol, the amount of lyophilic sol in milligrams. Okay, in milligrams required, in milligrams required to prevent coagulation of, to prevent the coagulation of a 10 ml 10 ml gold sol. Okay, 10 ml gold sol by the addition of, by the addition of 1 ml 10% NaCl solution. Are you clear? 1 ml 10% NaCl solution is called gold number. So here what I told, the amount of lyophilic salt in milligrams is required. Yes, here 10 milligrams, in milligrams only lyophilic colloidal salt is added, is required to prevent the coagulation, to prevent the coagulation of how much, 10, how much gold salt? 10 ml gold salt. We are taking here 10 ml gold salt. Okay, by the addition of 1 ml 10% NaCl solution. Here by the addition of 1 ml 10% NaCl solution. This is nothing but gold number. That means here 10 ml gold salt you are taking in the beaker. Whenever electrolyte 1 ml is added, immediately coagulation takes place. To stop that coagulation, we are adding just in milligrams small amount of lyophilic colloidal salt. To prevent this coagulation of 10 ml gold salt, how many milligrams of lyophilic colloidal salt is required? That is calling as gold number. Are you clear, students? Once again, 10 ml gold salt to prevent the coagulation, to prevent the coagulation of 10 ml gold salt, how many milligrams of lyophilic colloidal salt is required? That is called gold number. Are you clear, students? This is the gold number, Nana. Now I will give you the formula, students. Gold number formula, Nana. So what is the gold number formula? What we can write gold number formula? Gold number is equal to, gold number is equal to number of milligrams of, number of milligrams of lyophilic colloidal solution is added, solution is added by volume of the solution into 10. So this is the gold number formula, students. Okay, Nama. So how many milligrams of lyophilic colloidal solution is added by volume of the solution? Means this is the gold solution, gold salt solution. This is lyophobic solution volume into 10 we have to take, because how much we are adding, students? 10% NaCl solution we added now, 1 ml 10%. That's why we are taking 10. Are you clear, students? This is the gold number. Now see, one problem we'll discuss. Okay, students, this is about the goal number formula. Now, in the next section, students, I will discuss the goal number problem. Students, already this video is lengthy, so I'm going to discuss the problems based on the goal number. In the next video, I will discuss today. I will discuss, students. Please try to understand. I hope you like this video, students. If you like this video, please like, share, comment, and subscribe my channel, Lana. Okay. Thank you very much, students.